Turn into an interpretation class. You know why the margin of error exists now. Does somebody say thanks? Good, you're welcome. I appreciate that. Get her in focus. And focus-ish. Fire them up. That's not really in focus, is it? If you go back a little. Oh, that's better. Is that okay? I won't run you over, and I promise. I won't run you over. We're good. We're good. So fire them up. We're kind of in focus now. This feels like I'm closer to the wall than I was. Are you guys further forward, or am I just not caffeinated enough yet? Not caffeinated.
I don't know.
It's okay. Don't worry about it. You're still recovering from when you run over by a projector. Press the stat button. You spent a lot of time in here back in 243, I imagine. A lot of time back in 243. We never spent any time here, though. This is the 244 menu, the tests menu. It's my favorite. Well, it's my favorite 244. Go over to it. There's a lot of stuff in here, and it's all written in TIEs, which is unfortunate. It's very unfortunate. TIEs means that it's all written like it was 1984. A lot of acronyms, a lot of shorthands, a lot of limited space, a lot of ellipses. Your job is to be able to get into this menu whenever you need to and find the thing you need to use. So what are we constructing right now? What are we constructing right now? A confidence interval. I want you to scroll through the list and look for any parts of the acronym that look like confidence interval. Anything jump out at you? Scroll through a couple times if you have to. You see C interval, very good. I see a T interval as well. All right. Two sample interval, right? Prop int. That makes me happy. Prop int. What do you think prop stands for? Proportion. Yeah. So the one you need for this particular kind of problem is this guy right here. 1 prop z int. Rory.
So I have those from 243 when you installed it?
I never installed these. These were actually stock.
Cool.
I installed other stuff too, which we'll get to later today.
Cool.
One of which we'll get to later today, and we'll tap into that as well. And they should still be there unless you changed all 5 of your batteries. Good. That's the one we need for right now. Prop. Now I understand that there's a Z in there, and you might not. Does anybody know why the Z is there? Good, because we did use the Z-score, did we not? When we were making the margin of error by hand, we put in 2 for 2 standard deviations. 2 Z equals 2. Good. Grab him. Whoops, wrong button. Now when you get out to this, it's like, oh my God, look how simple. It asks you to put in X and it asks you to put in N. Yes, 65, 702, and then it says how confident would you like to be? And we're, right now, while we're learning this, let's keep it at 95%. I do want to futz with that as we go through the course. But let's keep it at 95%, we'll learn the ropes and then start futzing. You can put 9.5 or 0.95, it doesn't care which. It doesn't matter if it's a decimal or a whole number. That was a nice change they made in the 83 as well. Then you just arrow down to calculate. Press enter. It thinks for a couple seconds. And when I say a couple seconds, I mean about 1/3 of a second. And pops out a couple things at you. The first thing it pops out is the actual interval. Yay! That took care of all that stuff for us. Yay! Then it pops out p hat. P hat is in the middle of that interval, as it has to be, right? Plus or minus the margin of error. And then it tells you the sample size. I don't know why it does that. You just entered that in. I'm not sure why. It's like, hey, did you remember? So, actually, of these 3 things, the only thing you really need is the top one. That's the interval I'm asking you to find in this first one. So it's about, what's that, 7.1% up to about 11.4%. Let's add it to the number line over here. Yeah, let's add that with a key. We'll make it colorful. I have orange in my pocket. Do. So, October, when I say October, I mean January, 2010. Jeez. 7.1% to 11.4%. 7.1%-ish. I'll make it low, we'll go higher. To 11.4%. And if I drew this somewhat to scale, 9.3% should be roughly in the middle. So I didn't do the best job. It's probably a little bit too far to the left, but you get the rough idea of where it should be. The middle should be right about here, and that should be about where 9.3 is. And it's close. It's probably a little bit too long on this side, but close, ballpark. If you need more precision, you make a computer draw it, of course. First of all, everybody cool with the move on the TI? We'll do it like 3 or 4 more times today until we understand it, in case it didn't make sense. Once we get that locked down, that's just the mechanics. That's putting the descriptive statistics, as Brian said, putting that into the machine and letting the machine regurgitate out the inference. The inference. I got a question for you. You guys keep saying plus or minus the margin of error. I love that, by the way. You keep saying plus or minus the margin of error, plus or minus the margin of error. What is the margin of error on this? If you had to tell me, and you could be ish, what is the margin of error on this interval? Ish. Ish.
2%.
I hear a vote for 4 and I hear a vote for 2. I love that. This is good. Split the difference, call 3? That's what the media does too.
I got 2.2.
2.2? Precision. Tell me your name one more time.
Connor.
Connor. Brian Connor. Yeah? Okay. Connor, tell me how you got 2.2, this level of precision.
I just took 9.3 minus 7.1.
So remember, that very nice by the way. The margin of error is added and subtracted to p hat. So it must be, if you look at the screen over here, I think this is what Connor did too, whoops, that the distance between p hat and the lower interval has to be the margin of error. Because to get from p hat to that number, you subtracted the margin of error. Conversely, the distance between that guy and that guy has to be the margin of error because it's plus or minus. So 9.3 minus 7.1 is going to tell you how big the margin of error is. So it's about 2.2%. The whole interval is about 4.4%, right? But that's 2 margins of error, one down, one up. So about 2.2%-ish. If you need more precision, let the machine do it for you. But that's a ballpark. So if this was a Gallup poll, you'd actually see at the bottom, plus or minus 2.2%. Please tell me your name again.
Me?
Yes. No. I thought I saw a question coming. I saw the hand in the pit. No, it's just processing. Sorry. Amphibian. Jump on motion. Is that believable? So, and I very rarely will ask you for the margin of error. I'll say, what's the confidence interval? I'm interested in that. Why am I interested more in the confidence interval than the margin of error? Why do you think? Why do we care about confidence intervals?
To make sure that our answer lies within.
100% sure? 95% sure on this time. So, tell me how you would answer the question, because the question was, what percentage of all Bend for-sale homes were in foreclosure? How would you answer that? How would you answer that, Chris?
Between 7.1% and 11.4%.
You 100% sure about that answer?
95% sure.
Boom! That's what you have to say. I'm 95% confident. Now, get used to saying this.
Okay.
You can actually just say, I've calculated it's between 7.1 and 11.4. Anybody in research go, what's your confidence level? They're going to ask you what confidence you use. They're going to assume you use 95% if you didn't tell them. So but the idea is though, you're uncertain, but you're minimizing uncertainty by making this wider. So by giving it a width of 4.4%, 2.2 on either end, you're eliminating some of that uncertainty. Is there a chance the actual value is down here somewhere? Of course there is. Of course there is. Is there a chance it's up here somewhere? Of course there is. Right, there's a 5% chance we missed it with our interval, right? Unlucky. Right, how random. No, how unlucky. There's a 5% chance we just got deviant tail and bell curve data. But there's a 95% shot that what we're looking for is in this range of values we just calculated. That's why I care about the... Sean, answer that question.
No, I'm good.
You're good. Okay, I misread the face.
It'd be worth
Calculate.
betting on.
It'd be worth betting on? If you bet.
Yeah, you bet.
I got in this discussion with a guy, posted a picture, me and Max were playing roulette, a little baby roulette wheel. And he spun the roulette wheel 5 times in a row and got 5 black spaces. And I didn't say anything, I'm just sitting there watching, I'm like, that's cool. And he's like, Daddy, why didn't we get any red? And I'm like, yes, my son understands outliers. And I posted it, I was so excited. And one of my friends from the East Coast goes, you know, did you come from the same field? I'm like, what the hell's a field? He's like, well, there's 3 fields in roulette. You know, there's 1 through 12, and there's 13 through blah, blah, blah. And I'm like, dude, I don't give a crap about that. Well, if you're teaching him roulette, I'm not teaching him roulette. I'm teaching him how to understand unusuality at age 7. So when he's in middle school, he doesn't go around going, hell, random. He can say, how likely to happen over a long period of time? Then he has to deal with all the crap in gym class. But you know, whatever. Fair? Fair. Okay, good. Oh wait. Yeah, poor Max, exactly. He's got 2 math parents. Is that clock right? ish. I feel like it hasn't moved. Which is okay for me. I'll keep you guys here for 5 hours. I just don't want you to sit here for 5 hours.
95% confident.
95% confident it has moved? Okay, good. Let's just keep going then. Let's knock a few more intervals out, okay? So now let's go to